Today, we're going to tackle a really critical concept for anyone building with microservices: asynchronous message passing. It's kind of the secret sauce that lets different services work together without getting all tangled up in each other's business. Okay, so let's just dive right in. The fundamental challenge with microservices is this. You've got all these small autonomous services, which is great, but how do you actually get them to collaborate effectively? How do you do that without creating this giant web of dependencies that makes the whole system fragile and, frankly, a nightmare to change?
Well, to answer that, we first need to talk about a core architectural principle called coupling. It's really all about how much your services know about and depend on each other. And believe me, getting this right is the difference between a resilient, scalable system and, well, a house of cards just waiting to fall over.
So on one hand, you have tight coupling. This is where your services are basically chained together. If one service has a problem or needs an update, it can bring a bunch of other services down with it. It's like a domino effect. But the goal, the dream, is loose coupling. This is where services are truly independent. It gives teams the freedom to update and deploy their own stuff whenever they want, which is how you get both speed and safety. Now, this is where it gets really interesting, because you can actually create coupling even when you think you're avoiding it. You might set up a message queue between two services and think, great, they're decoupled. But if they're both reading from and writing to that same channel, they're still sharing a data space. They're tied together by the structure of that channel, which kind of undermines the whole point of their independence. So the crucial point here, the absolute key, is that true loose coupling enables what we call independent deployability. And honestly, this is the holy grail of microservices. It means one team can push an update to their service at any time without having to schedule some big coordinated release with 10 other teams. It just completely eliminates those bottlenecks and lets the entire system evolve so much faster. Okay, so this brings us to a really powerful pattern for achieving that independence: publish/subscribe, or pub/sub for short. Let's break down how this elegant workflow actually solves our coupling problem. It's a beautifully simple idea, really. You have a publisher service that generates some kind of event or update. Instead of sending it directly to other services, it just sends it to a central hub. Then you have other subscriber services that have already told the hub, hey, I'm interested in this type of message. When the hub gets a message from the publisher, it just broadcasts it to all the relevant subscribers. The publisher has no idea who's listening, and the subscribers have no idea who sent the message. They're completely, totally decoupled. All right, so let's get practical. How can we actually implement this? The great news is we don't need to invent some new protocol from scratch. We can build this entire workflow by adapting existing proven standards that are already out there. We can look to a standard called pub/sub/hub. It was actually designed to solve a similar problem in the world of blogging. How to get instant notifications when your favorite blog posts something new without you having to constantly refresh the page. We can take the core concepts of this awesome web-native protocol and just apply them to our microservices. No need to reinvent the wheel. So how does this actually work in practice? Well, we use something called hypermedia, which is really just a fancy way of saying the API itself provides links that tell other services what actions are possible. So instead of hard-coding everything, we can standardize a few key terms, or link relations. A service can advertise where its hub is located, and it can provide direct links to subscribe or unsubscribe. It makes the whole system discoverable and dynamic. Okay, let's put it all together. Here's the entire asynchronous flow. First, a client, our subscriber, discovers the hub link. Easy enough. Then it sends a request to that hub to subscribe. Sometime later, maybe minutes, maybe days, the publisher has an update, and it just pings the hub. Finally, the hub pushes that update out to the client. The key here is that nobody is waiting around for anyone else. It's a fully event-driven, totally decoupled model. It just works. So we've gone through the principle, the pattern, and the practice. What are the most important things you should walk away with from this explainer? Okay, first, the number one goal is loose coupling. Why? Because that is what gets you to true independent deployment. Second, the publish-subscribe pattern is going to be your best friend for achieving this, because it totally breaks those direct dependencies and avoids that shared data trap we talked about. And finally, you can actually build this today by adapting robust web-native standards like pub/sub/hub. You are not starting from zero. So this leaves us with a final, really critical question to ask about your own systems. It's pretty easy to get services to communicate with each other. The hard part, and where the real value is making sure that communication isn't creating hidden dependencies that are going to slow you down later. And that's all for this explainer on asynchronous message passing. If you found this useful, do us a favor and like, share, and subscribe. It really helps them spread the knowledge. We'll see you next time.